Hello guys, so we'll be looking at rate of reaction, and in this video we basically want to understand what it means when we say rate of a chemical reaction. There are some reactions that can occur very fast reactions. Now some of these very fast reactions, we can talk about fireworks, we can also talk about precipitation reactions. Precipitation reaction. Now, in a reaction like this one, we can have, that's what we use for the test for ions. So let's say we have sodium chloride solution, and then we add silver nitrate. What is going to be the product? We are going to have silver chloride, which is going to be a white precipitate, and then we have sodium nitrate. Sodium nitrate is soluble, so we are not going to see that. But this is going to be a white PPT. Now, this reaction occurs very fast. This reaction occurs very fast. So, precipitation reaction, this involves ions and it is a fast reaction. Okay. Now, neutralization reaction is also a fast reaction, very fast reaction. Neutralization reaction. Where we react an acid and a base. So we have sodium hydroxide and we have HCl, and this, you know what the product is going to be, a salt and water. This is also a very fast reaction. Other fast reactions include combustion reaction. Now we also have explosion. That's also like some kind of combustion reaction or fireworks. Like this reaction needs to take place within seconds, very fast. So these are very fast reactions. We can also have some reactions that are very slow. Okay, so let's say very slow reactions. Very slow reactions. Very slow reaction, we'll consider rusting. Rusting is a very slow process. It can take months, years to form. So when you have iron reacting with water to form iron oxide, and maybe some moles of water attached to it. So this is rusting. It is very slow. We also have the composition of organic matter. So the composition of organic matter is also a very slow reaction. Now, formation of coal, we can talk about weathering of rocks. All these things are very slow processes, and we'll say that they are very slow reactions. But the thing is, reactions that are very fast, we are not really interested in studying them, or very slow. We don't spend too much time studying very slow reactions. We are interested in reactions that are moderate, okay, in between. And then what happens is we study to see how we can adjust the factors that will affect the rate in order to have a good yield in those kind of reactions. So let's say we have moderate reactions. Moderate reactions. So let's look at some of those reactions that are moderate. One of them is a reaction of magnesium with dilute hydrochloric acid. So magnesium with dilute hydrochloric acid, you know what the product is going to be. You are going to have magnesium chloride and then hydrogen gas. So this is a typical moderate reaction. Now there are other kinds of reactions that are moderate. We can also talk about the composition of hydrogen peroxide. Decomposition. So hydrogen peroxide can break down to produce water and oxygen and oxygen gas. So that's the decomposition. Now this is a moderate reaction. Now we are very interested in this kind of reactions to see what will happen if we adjust the various factors that affect the rate of this reaction. So I've been using the term rate. Now if we say rate, we are basically talking about speed. We're talking about the speed of the reaction, how fast the reaction can occur or how slow the reaction is occurring. So this is rate. Okay. Now let's take a moderate reaction such as the reaction involved with the Haber process where we have N2 gas with hydrogen gas giving us ammonia. So 2 moles of ammonia. That means we'll put 3 here. Okay. Now this a reaction that is moderate. Okay. Now if we talk about the rate of the reaction, then we are looking at how fast this reaction can occur. How fast this reaction can occur. So there's a mathematical expression for rates. Rates, we'll be looking at the change in concentration. Okay. Change in concentration. Now we use delta to represent change. We use delta to represent change. And remember, we use a square bracket to represent concentration. Concentration. So we can look at the change in concentration of any of these species if it is reactants. So let's say reactants over the change in time. Over the change in time. Now, this is looking at the change in the concentration with respect to time. So, if it is reactants, we would like to add a negative to the concentration to show that the reactant is being consumed. Because as the reaction progresses, we expect that the concentration of the reactant will decrease. Okay. Now, this can also be equal to the change in concentration of the product over the change in time. So this is the rate of reaction. Now this is going to be positive because as the reaction progresses, we expect that the concentration of the product would be increasing. Is that okay? So this is how we measure rate. Now, what is going to be the unit for rate? Now, this is concentration. Concentration is measured in moles per dm cube, and time is measured in per second. Okay, so this is going to be moles per dm cube per second. Moles per dm cube per second. All right. So maybe if the reaction is very slow, then we can use minutes or hours to represent the units for the rate. This is how we measure the rate of a reaction. Now, if we want to take each of these reactants or the products, we can also write a rate expression for it. If it is nitrogen, then it's going to be, we'll say that rate with respect to nitrogen is going to be the decrease in concentration of nitrogen gas over the change in time. Over the change in time. So basically, rate has to do with the speed of the reaction and how it varies. It varies when we change certain conditions. Now, these conditions are what we call the factors that affect rate of reaction, and we'll be looking at them.